So let's look at limits by factoring. Okay, now essentially I know off the bat pretty much in all these problems it's a good idea to start factoring things. But what I'm going to do to really draw out what's going on in this problem is I'm first going to try direct substitution. It's going to take a little bit, but I really want to draw home the idea of what's going on here. Every time, technically or theoretically, you should try direct substitution. However, if you look at a problem like this, you should also equally say, oh, I can factor this somehow. All right, so first let's just try plugging in -5 directly. We could actually get an answer that's totally acceptable. 50 times -5 all over -5 squared minus 25. All right, when I do this work here, this is going to be positive 25 times 10 is 250. 50 times -5 is negative 250 over. On the bottom, you're going to end up having positive 25 minus 25. Now this is 0 over 0. Again, that doesn't mean the limit doesn't exist. It means there's something you can do to your function. And that's why this Khan Academy is called Limits by Factoring. We can do something to this problem to actually see what our value of our limit is going to be. Because this is not an answer. It means more work needs to be done to get our answer. So what I'm going to do is I'm going to factor the numerator and denominator individually. When I do that in the numerator, I can factor out a 10 and an x from each term. And when I do that, I'll be left with a single x and plus 5. So again, just redistribute this and see how I went from what the numerator was to what I got here. Hopefully that makes sense. In the denominator, it's been a while, but we have a very special quadratic down here. This quadratic is a difference of squares, and that factors to x minus 5, x plus 5. If you need to see why that is, please just YouTube difference of squares or factoring techniques. You should definitely be comfortable with those by now. So from there, let's see what happens here. When you look at your numerator and denominator, both of them have a factored x plus 5, and we can cancel that out. And we're just left with this. Now the idea is, let's try and take the limit of this now. So in other words, we now look at what is the limit as we approach -5 for this. Now also I'm just going to say I'm not using totally correct notation, but I'm just showing you how you're approaching the problem. So you had your original function, it gave you 0 over 0. You found ways to algebraically simplify that function. Now you're finding that simplified function's limit at the same place. So now when I plug in -5 in the numerator, I'll get -50, and in the denominator, I'll get -10, and so really that's just 5. So see, we went from something we did not have an answer to at all to something that we go, oh, 5. All right, now I'm getting close to my time limit on this video, but I'll do another problem or two really quick. Now what I'm going to emphasize here is I'm just going to start telling you up front, almost all these questions you should just start factoring right away. So in the numerator for this problem, again, I have a difference of squares that'll work out to x minus 4, x plus 4. In the denominator, you have a common x. All right, again, please foil these and just see where I got my answer from. Maybe that'll help jog your memory about how I did this. But from there, again, the idea is you can see those x plus 4s cancel out. So now we're left with x minus 4 over x. Let's take the limit as x approaches -4 of that. And that's going to give us essentially -8 over -4, which is 2. So again, in this case, here's what would have happened. If you plugged in -4, just trust me, you would have gotten 0 over 0. But rather than spending all the time just to realize that we could factor and simplify, we might as well just do that up front. So this time we got positive 2. And I'll go through one more example really quick. We have a more difficult question here. I have an x to the squared that I can factor out from each term, and I'd be left with x squared minus 4x plus 4 all over x minus 2. Now this time your numerator can also factor a little bit further. It actually factors to x minus 2 times x minus 2. Again, I'm skipping the factoring process here. that's something you have to kind of go back and review on your own. This time, notice we have two x minus 2's factored in our numerator. We only have 1 in our denominator, so that means we can only cancel 1 for 1. So now we have x squared times x minus 2. Now we've simplified it. Let's try to take the limit of the simplified form. All right, when you square 2, that's 4. 2 minus 2 is 0. Now 4 times 0 is just 0. Right? So at first, when we plug into trust me, you'll end up getting 0 over 0. Again, that means you have to stop and say something can be done. That it never means does not exist yet. And then, in this case, we were able to simplify it and get 0. Now you start to get a little bit afraid of 0, but in this case, since it's just 0, not a fraction, it's just 0. All right, well, I figured since I already went over, I might as well just finish up the Khan assignment. In other words, I already had to split this video into 2, so why not make the second video longer and give you a few more examples. Again, I guess since I'm not worried about time, just trust me, again, if you plug in 4 into this, you will likely end up getting 0 over 0. Again, you should also look at that numerator and denominator and say, I can definitely factor this. At this time, your numerator has a -5 and an x that can each be taken out of the numerator. And you would be left with just a single x and -4. Again, redistribute that, see how I got that answer. And then in the denominator, there's a common x that can be factored out. And after you factor that out, it would read like this. Now from there, there's more factoring you could do in the denominator. And you'll end up factoring and getting x minus 4, x plus 1. This time, your x minus 4's cancel, so I'm now going to get -5x over x times x plus 1. And now let's take the limit of that simplified form. So now what is the limit as x approaches 4 of my simplified form here? And what that is that's going to be -20 over 4 times 5, which is also 20. So we end up getting -1. All right, very next problem, or very last problem, and then I just want to make one big conclusion here. This time in the numerator, there's an x squared that we can factor out first. And in the denominator, there's a common x that we can factor out. And in the numerator further, before we start canceling things out, we could factor the numerator to also have x plus 5, x minus 2. In the denominator, again, we still have our x and our x minus 2. All right, this time's a little bit different because this time you factored out an x squared from the numerator and an x from a denominator. So in other words, there's 2 x's and 1 x. You can cancel those out 1 for 1. So now we have 1 x left over in the numerator, 0 x's in the denominator. Our x minus 2's cancel. So now our simplified form is x times x plus 5. So now let's try the limit at the same place of our simplified form. And when I plug in 2, this time I get 2 times 7, so my answer is 14. All right, so now what I want to spend the rest of the time doing is just really showing you what's going on in these questions. How are we going from 0 over 0 to some exact answer? What I'm going to do is just show you this on the calculator. And I'll actually just use the last example. So let me plug that into my calculator here. Again, you don't need a calculator to get through these problems. Clearly you saw that I didn't use a calculator at all. I'm just really showing you where all these answers are coming from. So we had x to the 4th plus 3x cubed minus 10x squared divided by, essentially we started off with x squared minus 2x. Now I'm going to look at this in a few different ways. Number one, I'm going to first just look at the general graph. When I look at the graph, it's going to take a little bit. Remember our limit value is 14, so I actually can't see 14 on my calculator here. I'm going to zoom out here for a second. Actually, I'm going to change my window to count for my y values, because since the 14 I can't see, I was really taking the limit at 2. I can see the x value of 2, but I can't see the y value of 14. So let me make this instead count from 0 to 20, so I know 14 is in between there. Okay, so 14 is going to be somewhere around here. You can see at the x value 2, it doesn't look like there's a problem at all. All right. Now this is the thing about calculators. Calculators don't show you what we call holes in graphs. And that is what's going on here. When you get 0 over 0, that usually means there's a hole in your graph somewhere. The calculator doesn't show that directly by its graph, but let me go and look at this as a table. When I look at, I gotta adjust my table settings. Let me start at 0 and count by 1, typically where you want to start. Now when I look at the x value 2, the one I wanted to take the limit of, it said error. All right. Now let me just show you kind of what you were doing on some of those questions before. If we start our table value at 2 and count by a very small amount, in other words, if we were looking at some function and we knew there was a hole there, then when we take its limit, we get very, very close to the value we want. We get very, very close to the value 2 from either side and see what it's approaching. All right, now when I do this and look at my table again, you can see at 2 there's a definite error, but look at what your calculator was doing. It's rounding and rounding and rounding and rounding, and eventually it gives up. So it's just saying 2 here, but really it means it's using a very, very close value. It's just given up on rounding. So actually, maybe I went too far. Let me count like this. It should be enough to see the idea. All right, you can see as you get closer and closer and closer to 2, this is getting closer and closer and closer to 14. This would be the right-sided limit because it's higher. On the left, you can see you're getting closer and closer and closer to 14 as your x values from the left get closer and closer and closer to 2. Right, now the idea is you aren't actually really seeing this happen as you work through the algebra, but it's definitely what makes your answer possible. Now the idea is there's a hole in your graph. How do you know there's a hole in your graph? Well, because you were getting 0 over 0. Now, sometimes that doesn't necessarily mean it is a hole, but usually it is. And if you remember from Algebra 2, whenever you had these rational functions and canceled something out, that is what you called a removable discontinuity. What that really means is, at first, when you wanted to plug in 2, you were not able to get a valid answer. However, once you remove this factorable expression out, you can now get an answer. You can see what the graph wanted to approach, although the actual function isn't allowed to be that value. Right, so again, at the end of the day, that idea doesn't have to totally make sense unless you plan on moving on to calculus, but what you do need to understand is just because you get 0 over 0 doesn't mean it's does not exist. 0 over 0 means there's work to be done. The calculator is approaching some definite value, right? In other words, let me try to calculate the value at 2. Calculate the value at 2. You can see it doesn't give me a y value, but at the same time, really close by to 2, it doesn't look like I should not be able to get an answer. And if I follow this up correctly, it should say 14 right here. Now, I guess to show you this one last way, go to Desmos. It's a little bit more interactive and can help you out a little bit more. We had x to the 4th, I believe it was minus 3x cubed minus 10x squared. No, it was plus. And that was divided by x squared minus 2x. All right, now again, in this case, when you look at the x value 2, there's no hole anywhere. But if you actually click through this graph, now you can see there is a hole here. That's why you are able to get an answer once you factor it. The graph doesn't look like it has a hole. Technology never shows you a hole at first. You have to realize that when you get 0 over 0, you're in one of these hole situations, and you need to factor or do some other work to get a definite answer. Right? Hope this helps. Again, good luck. And if you